Muy bien, bienvenidos a
Hello
todos.
and welcome to all of us joining us today. We will now then start the new workshop session under this context of LACPASS and the initiative Convergence. Today, we're going to be looking at terminologies. And as always, this session will be recorded so that we can keep it as backup, but also to make it available at the Raxel site. Remember that we have simultaneous interpretation available.
And our session will be recorded and available on the Raxel Moodle website. Muy bien.
Very well then. So without much more to add, let me now then begin. Hold on just a second. Let me make sure. I just want to be absolutely certain that I'm recording. Perfect then. Let me then start by introducing today's session. As you might remember from previous sessions in the technical committees and all of the work that we are doing under these convergence of initiatives, we've defined the technical roadmap, which is based on the IPS work that we have been carrying out throughout this month, and also based on what was done in the last workshop with the country technical committees. They are all publishing their country notes, and obviously they are interacting with the regional broadcast with the MHD profile and the transactions there defined in order to operate with these IPS. That's the phase that we're still in. And the objective is throughout this month to make sure that all of the countries are well leveled regarding this work, so that we can get to the workshop on June the 29th to work with the vaccination certificate. That's the roadmap that we have defined, and the deadlines that we have, the workshops, and everything else that we've set in the schedule. So we continue working on the base of this technical pyramid, and then we'll go to work with the vaccination certificates to be able to get them. Now, in this journey, always with the objective of getting to the connectathon, and the date will be stated in the coming weeks. It'll no longer be at the end of July. The final date will be determined in the coming weeks, and it will be well communicated to the technical committees. But the working tracks carry on: IPS, a vaccination certificate, and the optionals like signing these certificates with blockchain tools. What we have now in this journey towards the generation of the vaccination certificates based on the data that we're using in the International Patient Summary, IPS, is, well, we have these terminological tools and services. We have to understand what's available, what's exactly involved in them, and what's available for this case in particular. What has been developed and what has been put available in the LACPASS Docker obviously corresponds to the use cases that we're using under this context of the convergence of initiatives, but they are tools that are important that you understand well, to understand the possibilities that you have in order to extend the use of these tools for future or further uses, and obviously to make sure that terminological services is leveled in the region so that we can have these cross-border sessions. We're going to have them 2 sessions. The first one today is a little bit more theoretical, especially when it comes to terminology. And we have a second one for June the 15th that we expect will be a little bit more practical, but also using the tools available in this LACPASS Docker. Once we've gone through these terminology activities towards the end of June, we're going to move forward with the DDCC vaccination certificate workshop to see how to populate and to obtain it based on the data that we have in the IPS. So I really have nothing else to add. I just wanted to give you a very brief context. So I would like to leave you now with Marcelo Cabello, who is an expert from Sense in terminology, and he will be delivering the workshop today. So Marcelo, the floor is yours.
Gracias, Carlos.
Thank you, Carlos.
Bien, muy buenas tardes a todos.
Okay, good afternoon, everybody.
Mi nombre es Marcelo Cabello.
My name is Marcelo Cabello,
Me desempeño en el
and I work in Sense as an informatics or IT engineer. But in the last few years, I've been dedicating myself full time to understanding this world of terminologies and the existing terminologies that underlie the tool. So the objective of today's session and the one coming in the following weeks is for you to have a general knowledge of the different aspects of these terminological services and the surrounding elements, functionalities, and elements and structure, how they are organized, among others. So the idea is to give you a very general overview so that you can have a full and global understanding of what this all implies.
Vamos a ver brevemente un contexto general de
In today's session, we're going to look at the general context of terminologies. We are going to also see a little bit in more depth what the elements of a terminology is, how they're made up, and how they are connected within a terminological server. And then we're going to have a look at the best known standard terminologies, but commenting some of the technical features. And for the following week, we're going to have a session that's a little more practical, a little more hands-on. We're going to see the description of these terminology services and the FHIR terminology module, which is a limited set of resources in order to take advantage of terminologies. So let us begin then with the general context. And I want to mention a couple of things that you may be familiar with. In my country, for example, for the case of lab exams or X-ray exams, we have a terminology that is based on the price, on the charging. So, for example, and I do want to make the disclaimer, I am not a physician, so if I say any collegial nonsense, please be patient and understandable and understanding enough to know that I'm just using this as an example. So, as I was saying, a physician, a doctor could request for an exam to measure electrolytes. But for the lab system, that's simply not enough information because the lab systems needs to make a difference or needs to understand what type of electrolytes are or what box to put the corresponding value to, which corresponds to sodium, potassium, and chlorine. The same thing with an X-ray, for example, using these terminologies. For example, they request a elbow X-ray that has a given code associated to it, but all of the complexity of the exam, the angles with which that X-ray must be taken is not specified. Therefore, they have to fill that out with free text. So that code is for any elbow X-ray in whatever angle or with whatever other feature that the doctor may require. So that in itself sets a problem because how do you identify all of these indicators within the health system so that you can clinically differentiate what is what and who is who? It also creates issues when it comes to bids and tenders, because if you want to buy a new laboratory information system, this becomes complicated because you always need to evaluate the integration with your hospital IT system, which means carrying out analysis to see what can be integrated and what cannot, what interfaces need to be implemented, how many hospital and how many professionals from the company or from the hospital you're going to be actually needing, how many experts you're going to be needing. So every time there's a new system to be implemented, there are headaches involved. Another thing, for example, on the clinical record, I remember that some 10 or maybe some 15 years ago, CIE 10 was what was known in the health world as a classifier for diagnosis. And many of us, in fact, me too, we didn't really know the right target of the classification. So what many softwares did is they implemented a CIE 10 in the clinical record where the physician identifies the diagnosis. And since CIE 10 is a classifier or makes groups or bundles, it doesn't allow me to have the level of specificity in the diagnosis required to say what a patient actually had in detail. So what do we IT people do? Well, we take these systems and then we add free text so that the doctor, for example, can write, I don't know, diabetes. No, another example. Let's say he puts the diagnosis that has the code in the CIE 10, and then in the free text, the doctor can specify the findings or the clinical characteristics of that diagnosis. And these characteristics are not defined by the CIE 10. Therefore, since there is no integration of these codes with other services, like, for example, pathological anatomy that a CIEO could have, which is a classification for cancers and tumors, the interoperability becomes complicated. Something similar can happen in the pharmacy committees in hospitals. According to the public policies in the country, sometimes these facilities are restricted to having a pool of drugs, and that means having a pharmacy expert committee that defines this list of medications. And if they are not well acquainted with the clinical or the logistic scope that these medications can have in the information systems, then there could also be some inconsistencies. For example, we define the medication at the prescription level, but in the logistics database, we need to buy 500,000 pills because we don't have it by unit, by box. So they cannot make that conversion. And these committees are constantly updating this list in order to add or delete medications from it. So some keys to understand the terminology services. The problem is that in order to communicate, we use natural language. And this is very difficult to implement in a computer so that the computer can actually store it in a structural way with the objective of then trying to carry out any type of analytics. So we have these type of phenomenon. And natural language also means that in the IT systems, we need to make certain context explicit within the scope of what we're doing. So for example, if I'm at the beach and I say to my girlfriend, give me the screen. The screen is the sunscreen. But immediately, given the you assume, you understand according to the context. We're not going to give them the screen of a computer or the screen from a lamp. But the IT systems do not have this understanding of the context, and therefore we have to tell the IT systems within what context we are defining certain pieces of data. Also, a concept, an idea, can be expressed differently in different IT systems, as we can see in the example here. Hospital A, we have defined lung cancer through a drop-down list, and the status. In hospital B, we have it as two drop-downs, and in C, we have it as a diagnosis, suspected lung cancer, and suspected lung cancer in all three, yet different ways of deploying that. And then we also have some linguistic issues that are difficult for a computer to understand. For example, she's cold and she has cold. That's a literal translation from Spanish. It would have to be she has a cold, and therefore it has a totally different meaning. So in order to really start narrowing this, without the application of terminology standards, we cannot compare the data. That's basically it, because one system may define it in one way and another one differently, then making them to interact, it can cause certain difficulties in order to translate it from one end to the other. Not having these type of data also means that the analytics or adding data is also complex, because in my experience, for example, I have to go to one system to get things one way, and then a similar information is being kept elsewhere, but I need to request it differently because it's stored in a different format, and then it needs to be consolidated under one statistic report. So the exchange of data, both intra within the health level or towards other types of bodies, it becomes simply impossible. And this also has in the secondary uses of the information, like, for example, clinical research, or even trying to make our processes more efficient. I mean, let's not even think about establishing rules that link a clinical decision-making system, because if we don't have the elements well identified, well standardized, it's going to be very difficult to consolidate these kind of systems that are rather complex. So this is where we have structured terminology, and they provide a consistent meaning. And also, when we all use the information similarly, that promotes the shared understanding of the very same information. So it's also going to facilitate the interoperability between one facility and another, or between one service and a separate agency, or different departments within one same hospital. It also allows for processes for us to benchmark, because we're going to have the data that will be integrated. And this terminology is essential in order to have interoperability between systems and organizations. And it's critical also so that the information can be portable within the electronic health records. Because with this, a user can have their data, and if the information is well established, that information can be read at a different facility. Like some mobile applications that integrate data so that you can use them from one platform and then move them to another one. Now, how is this agnostically integrated or articulated? It has to do with the objective. You see, terminologies can have clinical objectives, financial objectives, or other types of objectives, and they're going to be modeled according to that objective. So from a clinical terminology, we have to have a well granular information so that it can contain as many clinical terms as a doctor can as diagnoses there are, but also there are some terminologies that are a group more, which allows me to do good reporting. And there are some others that are more financially focused, like, for example, the list of services with a certain value so that they can be used later when calculating the hospital bill of a patient. So as I was saying, in a terminological server, in a terminology server, then the terminologies are organized according to their target, according to what problem it is that they are solving. So here in the literature, I have used this pyramid model where we start from the bottom up with a natural language layer, which is language that we currently use to talk. It's a non-controlled language, and it comes according to the context, and this is the way that doctors speak too. But a little bit further up, the next one is the interface terminology. And this is also known as the thesaurus, because it's one of the layers that is the most difficult to produce. And basically what it does is that there's a whole set of terms or phrases or words that are used in a given area, in a country, in a region. They are pre-coordinatedly defined. That is to say, term by term. And the scope could be internationally recognized, but they could also be developed at the local level. They are focused on the user, that is to say, the doctor that's filling out the electronic health record, writing a diagnosis and looking at the services that he requires in the server. And the idea is that this thesaurus is rich enough in terms of the number of terms that it has so that it can really capture the medical intention and that it can then be filled with a formal concept, and that's what I will be explaining in the next layer. This thesaurus has controlled and dynamic growth applied to it, and you can enable tools in order to capture certain terms so that a committee can analyze it to see whether they can actually add to this thesaurus so that it becomes ever more robust. The next layer is called reference terminology or benchmark terminology. And here, this is the terminology that's used the most here. The gold standard is SNOMED. We're going to be looking at SNOMED later on. And it's the clinical terminology that is best known and most widely used clinically. It's created by an STO, the standardizing organization, and it is the hinge for the semantic interoperability. It's the basis for the semantic interoperability. It allows me to come to take the interface terminology and are also then related to the terminology outcomes. Each element is a concept or is a unit with a meaning of its own. And the concepts here also have attributes, and manage relationships between them, which allows us to do some very interesting actions at the ontological level, the production of clusters by aggregation or by inference. It's they say that it is not for the patient or for the user, but lately I've heard about the idea of putting this reference terminology in the interface in order not to have a thesaurus, but I don't really know whether that is recommendable or not. And then the outcome layer, this is where these clustering or classifying units are. The ones that are well known are the terminology from the WHO. Probably the one that you've heard the most is CIE 10, and there are others like CIE 9MC, SIAP 2, and FONASA. That's from Chile, but it's also oriented to the financial aspect. So one term in the layer of reference is translated into a concept that is broader under this classification terminology. Let me give you a very simple example. Let's say, for example, the classification is diabetes, and the terminology of reference that is mellitus 2, and all of the different types of diabetes are clustered into that, so that when we measure how many patients do we have with diabetes, they can be clustered there, and we can have a hit with all of them when we do that measurements. In terms of the elements of a terminology, and these are more or less mainstream, well, they have the concepts to begin with. The concept is an atomic unit. These are thinking units that could be real or that can be abstract. They are unique in a terminology. They can have synonyms, and they can be defined as singleton, that is to say an explicit explanation of that term, or post-coordinated, which means that from two or more terms, we create a new meaning. I will explain that later on in SNOMED. And these terms also have a coding behind it and have a representation of the concept in the human concept, in human language, so that we can understand it. They have an explanation what that term is about, and there could also be in more than one language. The concepts could also have relations. For example, it could be a mono-hierarchical relation like ICD-10, where we have first the chapters. I can't remember the technical term, but it's one with diseases, and then there's another one. Or the way that SNOMED does it too, which is the one that I know the best. It could have a polyhierarchy. That is to say, one concept can have one or more than one parent. Now, obviously, there could be terminologies here that do not follow either, and then they fall within the concept of a dictionary. For example, a list of countries or a list of districts within one country. That we can put into a terminology system like these ones, but there is no relation defined, and therefore they are in a dictionary. Another element that terminologies have are the value sets or reference sets. And I want to explain this with a very simple analogy. Let's say that our terminology is records, albums. So I have a pool of songs, and each song is a concept and relations. And if there's a song missing, well, I can record it and I can add it to this collection. In the case of value sets, it's either a set or a subset of the existing terminologies. So here I can group songs under a concrete parameter, all the songs from the 80s, or I can have very explicit definitions. This set is made up of these elements. Why is this actually done? Well, when we do implementations, and we're going to see that, but when we do implementations and we want to connect a part of the clinical information system, let's say allergies, I'm not going to have access to all of the terminology that's going to have diagnosis. It's going to have all the different types of allergies, infections, and vaccinations and medications. No, all I need is to get a subset of them that references to elements related to allergy. So this is the way that it's done. We create a subset of allergies. I give it the parameters for it to build it, and the server must interpret this in order to get that set and have it available for its implementation. So in this example, which is a little bit more elaborate on the value set, the first example is a subset. I got this from IPS, which is based on one system, one coding terminology, the way that it's called in the guide. In fact, if I click here, this is the definition of the code system. In Fire, it's called a coding system, and it has two concepts. Code, it has a display to understand what that code is about, and it's got a definition. Here we have the two of them. So it's a value set, a reference set with two terms. But I could also, if I need to integrate the information from more than one source, if it's justified, we can create a subset based on two or more sources. In this case, then I have one which is called problems, which is from SNOMED, plus some absent unknowns from the same value set that we saw before. So this one is made up of these codes, but it will also have the code in the SNOMED classification related to problems. The last point that's important here is the mapping. And I'm going to explain this with three different characteristics. There is a standard correspondence that can be downloaded, and from SNOMED to ICD-10, from SNOMED CT to CIEO, and I'm sure there are others, but they are the ones that are created by the standardizing organizations, so you don't have to build them. Why is mapping done? Well, as I was explaining in that pyramid model, it's done so that we can relate one term from one layer to another. And it's done like this because since they have different targets, that's the way in which they are linked so that we can have a connection between them. And it's not that easy because it's not about connecting A with B. It's here, there's other things happening here. For example, looking for a term here and it might not find it, or the term or the definition could be too broad, and therefore the meaning is not the exact same thing. So other types of relationships need to be defined in order to make sure that the term on the one end could be different in terms of the semantic meaning to the one that I'm mapping. They could be slightly different. We can also have a local correspondence towards standard terminology. For example, they can take national standards and you can map them to international standards, or maybe from certain health facilities. But we have to be very careful with this one. We have to know if the cost of carrying out this mapping is worthwhile or not, because it's a slow task, it's a long task, and needs to be maintained in time. And there's one additional thing that terminology services provide, which is automated mapping. But in practical terms, or as far as I have seen, it's not as automated as it sounds, because they do require the review of a human expert. There are tools that carry out this mapping, and in the simplest of cases, it does it with simple matching algorithms, stricter chains or partial matching algorithms, or algorithms of proximity, for example. You can test similar terms in one end to the other end, so the reviewer can then make the corresponding adjustments and make the real final matching. And then the very extreme case where we have machine learning or PNL involved, or also artificial intelligence, they are applied so that a system with reiterations can start carrying out the comparison and corresponding matching between one term and the other. Now, with ChatGPT and with MMLs, the artificial intelligence long models, it is possible to have a change in paradigm. But in the meantime, this is what we have. So the elements that I have just explained, I will have here in this relational model. We defined a model which is called aortic valve failure, and it could have several meanings in human language. It could be defined with, for example, an abbreviation with longer terms or shorter terms.
Marcelo, creo que lo perdimos, ¿no?
It seems like we've lost Marcelo.
Marcelo.
Marcelo, are you there?
Sí, al parecer Marcelo está
Well,
con
yes,
problemas
apparently
de conectividad.
Marcelo has some connectivity issues. Oh, Marcelo, there he is.
Estás en mute, tuviste un...
You're muted.
Sí, una caída ahí.
Yeah.
Adelante, Marcelo.
Ya. Seguía entonces, bueno, explicaba que el concepto, digamos,
I was saying that the concept could have several terms. You're not sharing your screen. Okay, there it is. So I was saying that these concepts, we have the concept here, and we have the terms, or the different terms that can be used to describe this concept. And then we've got the data subsets that I was talking about a few slides before. We can create in these subsets, you know, chronic diseases, or maybe allergies, or anything that you can think of based on the case that I'm actually seeing. But then I can do the mapping with CIE 10 or CIE 9MC, the way that they are defined in those standards. This is all put into a software which is called the Terminology service, which is a tool that allows us to record all of these terminologies. And then in the area which is displayed to the user, we can have the terms there so that they can be coded, so that we can find their underlying code, so that we can store the term. This code allows for the electronic health record to have the information coded and not with free text. And that's what the terminology server is about. And it has a countless number of functions.
Sus características como generales son...
Some of the main characteristics is that they allow for terminology services management. That is to say, we can add terminology, we can modify them, we can delete some, we can create relationships between one term and another, and these are ontological relations. It also allows me to have versions of the terminology, because we need to understand that these sources are alive and dynamic, so they change on a yearly basis, new contents are added, and that has to be intelligently, smartly managed. They also have terminology mapping. That is to say, this term from this terminology matches identically this other one, or has a broader meaning or a narrower meaning than that other one. And it also must allow, within its characteristic, the terminology integration with my own clinical system, so that I can say, for example, for my example, for example, allergies, I'm going to now integrate with an API. I will integrate to the value set of allergies so that I can select one when the patient has it. And then the other one is the search algorithm. It's just like when you are in a retail website, when you're looking, I don't know, for a specific model, a specific jacket, and you don't quite remember the name, but if you put certain characteristics, you can get to it. This happens because the search engines in the background have been optimized in order to search and then point to the concept that you're actually after. And it has other relationships. So, for example, it could have a spelling check, or it can take advantage of a certain hierarchy, or like when we do in Google, in YouTube, you know. What type of servers are there available? Well, this is a simple classification, but we could have the commercial service. There are several of those worldwide. Apollon is from Canada. We also, I wasn't aware of this one, clinical architecture and health language, and B2I, I believe that's from Hungary. And it has a very good page if you're interested. This is quite an interesting server. From Australia, it's called Onto Server. It has been well positioned in England recently. And other companies that we have seen are Valentia, and we have also been providing terminology solutions. And I can show you part of this next week. We already have a server that is capable of keeping the characteristics that I mentioned before, and we've enhanced the search algorithms in order to make it more effective for users. We also have open code servers. One is called Open Concept Lab. It's very good. This one you're acquainted with from previous presentations, Snowstorm, but it's dedicated in order to store SNOMED. And I understand that there's a version of the snowstorm, which is X, that can also store CIE 10. I don't know if it can also store other types. Happy Fire, which is open source platform too. It has the terminology modules enabled, so you could take a server in order to put together terminology and see the way that it performs. It is obviously not recommended for a production environment. And also in the cloud, we have Apple, and we have that in Amazon Web Services. On the other hand, we have other terminology servers that are more specific. The only one that I'm aware of here is Sense Pharma, which is made of, it's a homegrown, but it is about medication and also some commercial products. So how does the terminology server work? These servers have the possibility of responding to this kind of question. For example, what is this SNOMED code for a heart attack? The name, basically. So I have written here heart attack, and it's probably not the favorite term, yet SNOMED is able to identify it, and it gives me back myocardial infarction. It also allows for the code translation. What is the ICD-9 code for myocardial infarction? And since it has that relationship already stored, it can give me this answer. There are also grouping and aggregation, and I will show that in the tree scheme that SNOMED has. And it could also be for looking at relationships on how to deal with myocardial infarction. What drugs treat myocardial infarction? Oh, streptokinase. So the power behind this relationship allows us to have answers to these kind of questions. Let's very briefly take a look at the best known terminologies. I will talk briefly about their structure. So SNOMED is one of them. This is the controlled terminology for using in electronic clinical records with the highest level of precision and importance worldwide. As we saw in the components, it's made up of a concept, descriptions, hierarchy, and relations. It is a polyhierarchy. And aside from that, we also have the possibility of putting together value sets or ref sets according to my own needs. But SNOMED also has a factory built-in reference sets that you can use. And that's what this terminology allows us to work. Working with this reference layer, it allows us to have the appropriate display of the different diagnoses. So it's a polyhierarchy, as I was saying, and each SNOMED concept is related to other concepts. And it's done like this, and not only to give it a certain order, but also to make sure that there is a relationship between one concept and another, gives it semantic richness and wealth so that it can be better understood. And also, it has other types of relations, which are the attribute relationships, in order to define certain specific things to concepts. For example, if we define a broken hip bone, we can have laterality as an attribute, and there we can have left, or right, or both. That's the kind of values that we can have in it. So this is the structure of SNOMED. We have the concept. Through the SNOMED identifier, we can have access to that concept, and that concept could have several descriptions, as you can see on the left-hand side. and it has a full description or fully specified name, FSN in English, and it could have several synonyms. And those synonyms could also be presented in different languages, and some synonyms can be tagged as acceptable, words that are most often used than others. And then on the right-hand side, we have the relationships with the concept. We have either that is to say one relationship, one, I don't know, we can say a cold is a type of communicable disease or things like that. Or also attribute relationships, like, for example, laterality or the severity of a given condition. We have the same example here of the myocardial infarction. This is the SNOMED ID. We have the different descriptions here. And the FSN, the fully specified name, has the full description, and the other ones are synonyms. And out of all those synonyms, 2 have been called as preferred and 5 as acceptable. And that's the way that a term is in SNOMED. I mean, and it's just the term, I'm not showing relationships here. And then one thing that's actually very interesting is SNOMED, and it's very simple to explain, is the expression constraint language, ECL. It's a syntaxis in order to represent a data set through SNOMED expressions. And a SNOMED expression is a structure that combines one or more concept identifier, relating them to some inclusion or exclusion operators. In Spanish, this means, or in English, this means like selecting a term with a simple set logic. For example, that it has all the medications. And I know this from before, but this code, 373873005, is a category of biological pharmaceutical products. And I have access here to the SNOMED browser for you to take a quick look at. Let me go to the English version. And with this expression element, this symbol here, lower than, gives me all of the children from this concept, and it gives me 25,237. And these are all the products under, or medication, basically, medications under this concept. So it's like a simple set theory logic, because that same instruction can be included here with a minus, and then we can then subtract from there vaccinations, for example, which is part of this subset. So with minus all of the children from the vaccine products. Remember this number, 25,237, and now this has gone down to 25,038. That is to say, the difference is all of these vaccinations. In fact, if I do the opposite exercise, we can see that it's 199 concepts, which these are the vaccines that were deleted from before. It's as simple as that, really. And that's how the subsets are built. The other terminology that's interesting here that can be in the reference layer or in the outcome layer is LOING. This is the logical observation identifiers names and codes. And the target of this terminology is for labs. It covers all of the lab aspects, clinical chemistry, hematology, serology, microbiology, but also for other clinical aspects. For example, it's like an extra. For example, vital signs, tests, observations, and there are scales like the one from intensive care, Apache, Glasgow, and also it has a radiology study. So you have to understand well the target of the terminology to know when to use them or not. Although it does have some radiology, SNOMED also has radiology, and there are others that also cover that. And then you have to see what the differences are in terms of semantics and how they are adapted to the case use. The structure of a LOINC term is different to that of SNOMED because the name is built from 6 different axes. The first one is the component or the analyte. This is a brief example so that you can understand it. So here I have cholesterol in LDL. The second axis is property, which is the mass concentration. Then the third parameter here is time, point in time, because there are some exams that it's that a point in time, and there are some others that require a period or a range of time. Specimen, in this case, it can be serum or plasma, but it could be urine, it could be other types of tissues. Scale, that the result is measured with. In this case, it's quantitative. We also have ordinal or nominal. And this method this is optional. This is when there is more than one technique in order to obtain the result. In this case, we just it has been put as a direct assay. There could be others, and the term is built like this, as you can see here in green. Cholesterol in LDL MCNC, which is an acronym for the coding for the mass concentration. Pointing time, it's a serum or plasma measured with a quantitative value through a direct assay. And here, this is the second element, glucose, that is to say sugar in the blood, also has similar parameters, but the 6th point is not measured because probably there is only one way of measuring it. So LOINC also has several other characteristics. For example, the panels. Here we have a lipid panel, and what it measures is a package, so as to speak. So that panel within it has included cholesterol, triglycerides, LDL, HDL, VLDL, and therefore you don't need to define one by one when you do this kind of implementation. And it also has one for answering questionnaires. For example, when they have these kind of surveys. In the syntactics, here you can see on the left a segment of HL7V2 ORU message. This is the LOINC code, 26453-1. And this is the LNI indicator, which is the one that is used in order to define a LOINC code and the value. And in the case of FIRE on the right-hand side, this is done on the coding side of the resources. For example, observation, specifying the code system, the code itself, and you could also add the display. In this case, it's a hemoglobin in the blood. And the third one that I was talking about is Sense Pharma. This is a product of ours, homegrown, but it's capable of establishing a relationship between active principles and medications and commercial products. In our country, for example, in Chile, it is forbidden to have a prescription according to the brand name of the medication. what the doctors must do is make a prescription according to the active principles that the brands are made of. So if I'm the doctor here and I only know the name of the brand, through these relationships, I can get to the clinical medication. I have here Cotibin Plus, and this basically is a caffeine 50 milligram and paracetamol 500 milligram in a pill. So this is a product that we've applied for some time and we've had some very good results. ICD-10, I'm going to go very fast now because we're running out of time. CIE or ICD-10, as I have said before, is used for statistical morbidity or mortality purposes. That is to say, you're not using it in clinical records because it's actually counterproductive. As far as I remember, this manages about 15,000 concepts that are distributed in 22 chapters. These chapters also have a hierarchical segregation, which is really not that difficult to understand, but these classification group things, classify them, and then help in the creation of statistic. Work is later evaluated to look at the performance between the different facilities, for example. CIAP2 is similar to ICD-10, but the target here is for primary care. That's what CIAP stands for, International Primary Care, Primary Care International Classification. We have different chapters according to the different letters, but this tries to find the reasons why patients go to a primary care center. I understand that it's currently in 20 languages and it also has the ICD-10 mapping. And this one, which is the latest one from a couple of years ago, ICD-11. And this is totally different to ICD-10 or CIE-10. ICD-11, for us to understand, has the family of international classifications from the WHO, and they are an ontological infrastructure where there is a foundation component that includes, according to its description, it has a number of ontologically related identities so that they can then have separate classifications. And ICD-11, the mortality and morbidity, the core MMS, I can't remember what the S stands for, well, comes from that foundation component, as well as other classifications like ICHI and ICF, and they are known as linearizations. And I know that the terminology is sometimes a bit complex. The foundation component has about 17,000 codes, but then that gives us the pathway in order to code 120,000 terms. And I was reading in the technical documentation today that with the coding algorithms, you can even get to 1.2 million terms, which is absolutely madness. Unlike the previous ICD-10 codes, instead of having the one that we know, this has a URI, which is an address. And with that, you get to the term definition. And then other tools like a transition from ICD-10 to ICD-11, transition tool. I'm very curious to see how it works. It also has a coding tool. I was looking at it.
Porque aquí, como está
And it looks
abierto,
quite powerful because since it's available in a platform, it allows for the users who understand this terminology, if they come across something that is required or that is not included in this classification, they can suggest it for it to be considered. There's also a multilingual force there behind it in order to provide our ICD 11 in several languages. And it's also has a standard API. You can download it in Docker, for example, in a Docker Compose, enable it in your infrastructure and start consuming it. And that is what we have until today. That's all I wanted to share with you in terms of terminology. Do not forget that next week, we're going to have a more practical session on the functionalities that terminology services should have and how that is implemented in the FHIR terminology services. I hope that I've not bored you to death with all of these definitions, and I'm open to answering questions. Thank you, Marcelo. We're a little late, but if you have questions, maybe we can answer them. But if not, we can then maybe address them in the coming session. Although we're going to be looking at more practical things, if there's any pinpointed question, but if not, we can leave it for next session. We can maybe answer them at the beginning of the coming session. No hands are up, so thank you very much for coming to today's session. Let us not forget that it'll be recorded and it'll be in the LACPASS YouTube site channel and also in our site, and we will see each other on the 15th, where we will be looking at more practical tools related to these topics that Marcelo has shared with us today. Thank you so much and have a good rest of the week. Thank you, everybody. Bye-bye.